What we're going to talk about today is the Mainframe Application Tuner product, which is, I think, kind of self-explanatory as to what it is. It's an application tuning and performance product for the mainframe, and it consists of actually several parts, but we'll get into that in a minute. And the reason you'd use it would be, well, really systems programmers, database administrators, and primarily applications people can use it to check for bottlenecks, find performance problems, and look at their just overall utilization of the system and tune their products accordingly, and not just their products, but the subsystems and applications that are running on their mainframe. Then we'll also go through a couple examples of how to use the product, a little bit of drill down just to give you a sampling of what it looks like. And the GUI review, we sort of cut that down because it would probably take too long, but I will at least mention the GUI and show you one or two panels, and then we'll open it up for questions. So that is our agenda. Let me scroll us forward here now. Here we go. So what is CA-MAT? It's as I said, the Mainframe Application Tuner. It's a product that identifies performance delays. You can read this along with me, but the main purpose of it really should be geared toward applications programmers. I know products like this are frequently the domain of systems programmers, and 2 or 3 people in the system look at all these sorts of reports. But the way MAT is designed, it really allows anyone to get into an ISPF, or for that matter a GUI session, and analyze the performance of their particular application. It allows you to do testing at different points. So if you're developing an application or a program, you can set up MAT and take a look at what kind of issues there might be, and then as you develop further, you can see what kind of progress you made. The kinds of monitoring you can do is for batch jobs, obviously, but also on a whole variety of subsystems, which we'll show you in a minute. And hopefully it would, in fact, for customers who are using it, it does really buy you back productivity on your system. Let me go to the next slide. Well, right, these are all, I think, self-evident. If your applications are running better, then you can put off mainframe upgrades, or you can save money on other systems. The benefits are obvious if you're improving application performance across the board on your mainframe. In the long run, it's a big money saver, particularly if you can identify the sort of heavy hitters, or the applications that you know are causing you problems, but you don't know what to do about them. Some of the things that MAT does, which most application performance tuning products would do, would look at, CPU, I/O, enable you to pinpoint code and issues that are slowing up your applications. It allows you to look at all different kinds of languages, obviously, and all different kinds of subsystems. I mean, all of this I think you would expect, and in any kind of product like this you would find. But I think the thing that makes this product a little more usable and more friendly to applications people is the combination of the ISPF panel drill down. You're not just looking at batch reports, you're looking at interactive ISPF panels that will show you all kinds of different information you can drill down to. And the same functionality is available on 2 different versions of a GUI. I think that's a real strength of the product. It gives you that kind of power for the user, not just for a systems programmer leafing through a bunch of reports. So again, some of the things you can look at and highlight. Obviously, all ZOS-based applications can be measured, and we can correlate all the activity of a subsystem or a database or file I/O to your application. We can expose code problems or database activity issues, I/O inefficiencies. We allow you to measure multiple steps of a single job. And this is not a trivial issue either. You can set up MAT to go across the sysplex. So you can look all the way across all your LPARs and see how your performance is. Again, that ISPF drill down interface and GUI allow you the power to really look at an application and not just a high-level system kind of information. The way MAT works, well, let me back up a little bit. There's sort of 3 components to MAT. And the 3 components are server space that you bring up and whenever you're going to use MAT is running all the time, a TSO client or a GUI user, and then the actual target address space of whatever you're measuring, whatever application you're measuring. And MAT actually has code that will run in all 3 of those places. The way it works is it is a sampler, it's not a monitor, so you'll take snapshots of that application as often, as quickly as 10 milliseconds. And typically you won't turn it on for very long. You can run a MAT measurement for a minute or 2, or you can run it for 5 or 10 minutes. It's not a monitor, so we don't advise you to let it just sit out there taking the measurement of your, a KICS application that's running for an hour. That will not be useful information, and it'll overload the monitor data set. So it isn't a monitor, it's a sampler. But that when you put those samples together, you get a really good snapshot of what's going on in your application. And one other caveat to that, and that is we do have some pieces of the code that act more like a monitor where there are intercepts. There's intercepts in IMS, and there's an intercepts in DB2, and also on the phone is Glenn Hanna and Joe Amendola from the team. And Glenn, Glenn, can you hear this? Oh, okay. Well, okay. So never mind. Glenn and Joe are listening, but they can't connect to the WebEx, so they're just listening. At any rate, I think there's one other subsystem that we may have. Do we have intercepts in anything other than the IMS and DB2? I think those are the only intercepts we have. Or do we? MQ, I'm sorry, I knew there was one more. Okay, I'm sorry. We also have intercept. The reason I mention that is that does provide monitor-like data. It's not sampling, so we can get you all the SQL for the period of a measurement, or all the IMS data, all the MQ data. And we use that to help you drill down and get more information about what's going on. But in general, it's a sampling product, and we'll take samples every 10 milliseconds unless you can specify the interval you'd like. Yeah, there's not really a ton of overhead because of the way the product's designed. We make use of a disabled interrupt exit, and that's where we gather the most fundamental data that we're going to use. So in that instance, Matt does have actually access to everything on the system, but it's only for this brief snapshot window, and it really doesn't cause a lot of overhead, typically less than 2% when you're doing measurements. That's unlike some other measurement products that can be, you know, this is a technique that allows you to avoid being at all invasive in the application. You don't have to change any of the jobs that you're measuring. You can do it all from the outside. In fact, you can even, from the main panel, you can just do a display active on your system and take a look at what's out there and say, gee, I didn't realize this program used so much CPU or was so I/O intensive, and you can turn a measurement on straight from that panel and take a look at what it's doing for that minute or 3 or 5 and get very useful information. So we don't borrow any private storage from the application. Most of the storage we use is in the server, although in the case of the intercepts we do use some storage within the DB2 and DB2 and IMS address spaces. Right, as we said here, sampling and runtime for DB2 and IMS. Let's see. As I mentioned, we do have parallel sysplex support. There's content help on everything you're looking at. So if you're looking at a measurement after the fact from your TSO or your GUI, there's information about what you're looking at in the help. There's an ability to schedule. You can set up repeating measurements, and you can schedule them for a week from now or for the weekend, or and there's a MAT API that allows you to connect to other products, including SysView. We have a data we can produce in the CSV format, which can be used with our spreadsheet converter and can be used in any other way you'd like. Although I think with the ISPF panels and the GUI, you really have everything you need. We also allow registration of what we call registration of the listings of products, listings of applications. So if you have a COBOL program and we show you the statement offsets of where activity is, if you register the listing, you can actually look at all the verbs and see exactly which ones are using up all your CPU or resources. Yeah, this is sort of a reiteration of the things we look at: DB2, IMS, KICS, VSAM, TSO, MQ, IDMS, Datacom, AdaBase, and along with Datacom, you can look at ideal, and along with AdaBase, you can look at natural. And obviously, the simplest case of all is looking at a batch program. How are we doing on time?
We have 10 minutes.
Okay, and so we do have a couple of just drill downs of how you might use the product. So this is an ISPF panel in the MAT program, and there is a screen before this that you could look at that gives you an overview, and you can decide, you know, what types of things you want to look at. Do you want to look at the tasks? Do you want to look at the code? Do you want to look at a time view of how the sampling was done? In a data view, in this case, this would be a very normal place to start in trying to analyze an application. You'd look at delay view. And right off the bat, you can see that program active is your heaviest hitter, although there's data delay and KICS file delay. But program active is the big hitter here, and you can drill down and look further at that data. Now here's a code view example, and the actual transaction codes from kicks that are the most active, and you can see which one's in order. If you were, here's that code view that would show you that histogram that we just looked at. Here's a code view panel, and there's your heaviest hitter, that RGPOOT is the module, and the histogram says, actually we've got those backwards. The histogram will then show, you can put that H in there, that will show you the previous panel here. And there's your code distribution for that particular CSEC. Also, here's a histogram for what looks like a COBOL program. And as I said, if the program itself is registered, the listing, we can match up the listing to all the offsets and show you the verbs and which ones are using the most CPU or in this await state the most, or that can be really useful. That takes you straight to the code itself. As I said before, DB2 is heavily used. The MAT is used heavily for DB2, and this is a KICS DB2 application. And when you go into the DB2 view, which is one of your main panels, you can look at the actual SQL. In this case, you could say, okay, what's that top SQL statement, and you do a select on it, and you should be able to see the actual. This seems out of sequence. So you can show the detail on that DB2 statement, showing you the package information and all the various other, what kind of SQL it is, etc. And you can also look at the actual. This is very slow. Look at the actual SQL statement, the actual text. Now you'll notice on this panel it says SQL is not from the catalog. We can get the SQL text from various places, and if we're just sampling, we have to get it from the catalog. If we can, and if we don't get it from the catalog, we don't get it typically, or it's gotten from another control block where it may be less reliable. However, if we also are using the DB2 intercept, we don't even need to get it from the catalog because we've already saved off the text at the intercept time. And so it's actually probably more valid than the catalog, which could be out of date. Again, going back, we can look at who the caller IDs are of this module and who's actually invoking this, where we're coming from. And again, this is an example of the listing, and we can actually go into the listing and say, okay, this is where we were when this sample was collected. I said we were going to talk a little bit about the GUI, but I mean a very little bit about the GUI. We do have two versions of the GUI, one for each user's PC and one that's web-based. I think, if there's an interest out there, we can do a separate presentation on the Mac GUI, which is has its own world and a whole other ball of wax, and a good one, and I should not be the one doing that presentation because I don't know the GUI as well as I know the mainframe side. But just to show you, here's a GUI screen. This is the overview panel of a measurement. Shows you the name of the job and the steps. And this is the same information is available on from the ISPF panels as well. And as you can see, you can specify task and delay and code and time. Those are all available on ISPF as well, and they're all available through the GUI. So that's a super fast run through the MAT product. Just to summarize, it can solve major performance problems, help you optimize and evaluate. Well, I didn't even mention that. Evaluate third-party software as well. If you're looking at something, well, how much impact is it going to have on your system? MAT's a great tool to turn on and let you know. So I hope that gives you at least a taste of what MAT is and does. Any questions or comments or concerns? And Len or Richa, you're the ones who can open up the phones at this point. Actually, Ralph, the way we're doing these now is if anyone has any questions, please put them in the Q&A box in the WebEx. Oh, okay. Yeah, so fine. rather than opening the lines. So far, I haven't seen any questions come in. But we'll give them a minute or two to type if people want to type questions. Okay. Just so everyone knows, we are recording the session, so I will also be posting the replay and a webcast recap to the community either later today or tomorrow. So if you have any questions after the fact, you'll have a couple places that you can ask them in the community.
Thanks for the great presentation, Ralph.
Well, sorry for the technical difficulties at the start there. I got off on the wrong foot, but I hope it gave you a good clue as to how this product works and how useful it could be. All right, I don't see any questions, so I guess we'll wrap up. Ralph, thank you very much. Richa, thank you very much as well, and thank you to everyone for attending. And we'll be scheduling our next session very soon. Thanks very much. Okay.
Thank you.